data coming from the 5 participating countries. His presentation has the name GEOE3 Content Integration Platform. Lassi, you can start your presentation. Okay.
Okay, are you seeing my?
Yes, we can see your screen. You can begin.
Okay. And you hear me, I suppose.
Yes, we can hear you. You can begin.
Yeah,
okay.
Everything is okay. Okay, good afternoon, everybody, and warm greetings from Finland, far away from north. And my presentation is part of the GEOE3 project. And actually, there has been another presentation this Monday about the project generally, given by Nils Hempelman. So if you are interested in more generic presentation of the project, you can probably find the recording or presentation later. So in my talk today, I will focus on one specific part of this project, the development of a content integration platform, which we use to integrate content both across national borders and also aim at integrating content across domains, basically meaning integrating geospatial data with meteorological and statistical data also. So my agenda for this talk is something like this. First, a general introduction to the integration platform that we are using and developing. And then 3 specific subtopics on this platform: cross-collection query, feature dashboard, and concept of 3D buildings, and finally some conclusions. So the name of the project is Geospatially Enabled Ecosystem for Europe. And as I said, you will find this Nils Hempelman's presentation on Monday and find more general information of the project. So we are working together with 5 European countries: Finland, Norway, Estonia, Netherlands, and Spain, and aiming at creating a harmonized and integrated provision of geospatial data, specifically taking some selected use cases as a starting point for developing services and application demonstrations. So basically, we have built a platform for integrating content using a cloud platform, and here I list technologies and tools that we are using. In this technical development work, we have set up a cloud computing platform in which we run Linux service instance, use Apache web server, Django as a web application platform, if that happens to be familiar to you. And then core of the platform, I would say, is the PyGeo API product, which happens to be a reference implementation of the OGC's new OGC API family of standards, and specifically of the OGC API features access standard. Then we are using libraries like Rasterio, GDAL, OWS lib. So basically the service platform is developed in Python. So all of these libraries work as a Python libraries, and the system is developed mainly used Python as a programming language. In the client side, we use OpenLayers as a map library, and then a library called JS Viewer for 3D visualization of content. And this is running in a cloud computing platform, which is physically situated in Kajaani, like shown on this map. So the basic idea is demonstrated here in this illustration. We use Apache web server to provide content to the client side. We run Django as a web development framework in that cloud platform, and we run several PyGeo API instances as Django applications. So each PyGeo API instance provides a specific content theme, like buildings or digital surface model and so on. So for example, when talking about buildings, this is our current configuration. We are providing 2D vector formatted buildings through the integration platform, and as you see here, we have data available from all 5 participating countries: Finland, Norway, Netherlands, Spain, and Estonia. And each of the data content of these countries is represented as a collection, as a data collection inside a single OGG API features instance. So this way we technically integrate data coming from different countries inside a single service access point. And in the lower part, we see those provider modules. They are plugin modules that we use inside the PyGeo API instance to provide access to different remote services, like you see in the bottom. Most of them are country-level web feature services, and we use web feature service provider plugin to access those legacy services. We also access OGC API feature service from Finland on the left-hand side, and in the case of the Estonia, we currently have downloaded the content to our platform. So this way we collect data from different countries in most cases on the fly. It means we access the remote service in the moment of the query and retrieve the content from the national level and then transform it through this platform into the OG API features service interface and output it in GeoJSON. When talking about Raster Content, this is digital surface model. At the moment, we provide content from 4 countries. Right now, Estonia is still missing, and we access content from national level through web coverage service interfaces, as you see in the bottom. We use web coverage service provider plugins to provide again all of those contents as single coverages inside one digital surface model OGC API coverages instance. So this is the way to integrate the content coming from different countries. And then when it comes to really putting content together, we use so-called cross-collection queries. That's a concept that is defined in the OGC API features interface specification as a mechanism to query inside a single OGG API features instance across collections. If, for example, in this example, we are querying buildings from Finland and buildings from Norway by giving this collections parameter. So we are requesting features from these collections, and when our bounding box covers border area, like in this example case here, you see we get back features from both countries in a single query. So you see here in the right hand side there is only one search query going to the server side, and on the server side we integrate these two datasets together and get data from both sides of the border. In a similar way, when we are talking about OGC API coverages interface, again we can do similar search queries, cross-collection queries, requesting data from Norway and Finland again, and our bounding box again crosses the border or overlaps the border area. In this case, we run in the background two queries, one to the Finnish and the other for the Norwegian service. We run coordinate transformations as needed to get the datasets in the same coordinate system. We merge those datasets together, mask no data areas, and render the result as a PNG image. As a result, we get an illustration like this. So this is one single query going to the server side, and it integrates content coming from Norway and Finland and produces integrated digital surface model across the border.
5 minutes, Lassi.
Yes. Then feature dashboard, the concept which we have been developing. As you probably know, in OGC API features specification, they specifically want to provide content in HTML. It means that we are actually providing geospatial features formatted in HTML. And that's also, of course, rather open what kind of way we are using to visualize a geospatial feature in HTML. And we have been developing this concept of a feature dashboard as a way to visualize, for example, buildings in a use case driven way. So we consider certain use case, certain application area, and make visualization as an HTML page, as a web page of the feature designed to support that particular use case. For instance, thinking about solar energy potential application, we could use building 2D footprints and digital surface model content accessed from features and coverages service interfaces, and then format this data specifically for solar energy related applications. For example, here we have an example, first experimentation where we can select individual buildings in the vector map and get that building displayed on the right-hand side with analysis result that has been carried out on surface model, analyzing the amount of sunlight coming to each pixel of the building's surface. So it's an example of an application supporting solar energy related applications, and we see it as an example of this kind of feature dashboard. Finally, a few words about 3D buildings. That's an important part of our work. Have been developing 3D visualizations of buildings in the project. This is a complete picture how it works at the moment. I will not go into details, but you see that we use different ways to gather the 3D information from country level, and we have set up 3D CityDB databases on the platform. We have a custom database for Dutch content, and in the case of Spain, we access buildings encoded in KML format from a service interface in country level, and then provide content to the client side. And we apply CityJSON encoding here to encode the 3D information. just examples. Estonian building displayed in 3D module here. The Netherlands, the same kind of illustration or user interface. Spain again, and in the case of Finland, we have here also included the DTM content for the 3D visualization. Conclusions. This is part of the GEOE3 project, a 5-country EU-funded project that develops use case-oriented data integration solutions, and specifically we want to apply the latest generation of service interface standards, specifically the OGC API family of standards like features, coverages, processes. And we aim at cross-border and also cross-domain data integration. Here I mostly described cross-border data integration case in which we have made available specifically building content in 2D and in 3D, and digital surface model and digital terrain model content from five countries. And we have developed the concept of feature dashboard as OGC API features HTML output designed for specific use case applications. And we focus on 3D modeling and presentation of geodata in browser, and have got data available already from 4 participating countries in 3D buildings. So thank you, and this is a nice church from Tallinn as the last slide. Thank you.
Okay, thank you, Lassi. Excellent presentation. Just a quick question: why data from these 5 countries? Why these 5 countries?
It's just basically a consortium that we were able to put together for a EU project proposal. And of course, we are then working with data coming from those participating countries, and we have mapping agencies present in the project consortium from these 5 countries.
Okay. But is it still possible to include data from other countries, or not really?
Of course, we are always interested if somebody wants to join with data content without getting financial benefits from the project, but I don't know whether many countries will be interested in that kind of experimentation. But of course, we are interested in working with other countries' datasets too, if there is interest.
Okay, thank you.